Okay, so today we want to talk a bit about uh, importing other files into our program. Okay, what do we mean by that? So far we only done like one file programs, right? So when our programs get bigger and bigger, we have to write them in different files. Okay, so we're going to look at one example of that. Okay, this is all for us to uh, start writing unit test cases for our program. That's what we want to do. So before I show you that, I want to explain to you how, when we have multiple files in our program, how do we use those files in our main application. Okay, so always the entry point to our application had been the main method, right? That's what we execute, and then our program starts from that. That's our main entry point to our application. So here I want to create a file. Let's say I want to call this my math, okay, or my math functions. Uh, so in this I want to create a function called a function that calculates whether a number is a prime number. Okay, given a number n, I want to find out if it's a prime number. The logic here is not so important, so it'll go something like this. If n is equal to 0 or n is equal to 1, return false, or okay, else if n is equal to 2, return true. What am I typing? Elif. Else I want to do something. So what is a prime number? Prime number is a number that cannot be divided by any other number except itself and 1, right? So let's just do a for loop. For I in range, it's going to start from 2 to all the way to n except n. So I'm iterating, right? So if I find out if any of those numbers are divisible, like, so basically that means n mod I. If the remainder is 0, that means it can divide, right? So I want to return false. If it is divisible by any other number, that means it's not a prime number, right? So, and after I try all the numbers up to n or 1 less than n, I know that if my return statement didn't execute, that means it is a prime number, right? So this is my prime function. Okay, so if I want to test it out, I will write my main method. Let's say for I in range. Let's say if I want to print up to 50 prime numbers, if I or is prime I, then I will just print I. Okay, I just want to give it a space, so I don't go to a new line. I'm just going to print in everything in one line. Okay, so I'm going to call my main method. So this should print me all the prime numbers from 1 to or 0 to 50. Okay, or actually it's excluding 50, so let's put 51 just for the sake of it. Okay, so let's run this program. So it prints, seems like it's correct, right? 2 3 5 7 11 13 17 19 23. Yeah, so that's how you find the prime numbers. Okay, this is just in one example. There are better ways of doing it, but this is one of them. So suppose I create another file. Okay, some program that I need to write. Let's say my app or something. Okay. In this file, let's say my requirement is to somewhere along I need to given a list of numbers, I only need to return the prime numbers in that list, suppose. Okay, understand? All right, so I'll say get primes. So I'm gonna get in a list of numbers, and I only need to return if the number inside is a prime number. So I will create a new variable called primes. It's a list. So at the end of this, I need to return the primes. Okay. So I would do for I in list of numbers. Now I need to know if it is a prime, right? If I is a prime, then I need to put I in primes. Okay, and then at the end of this for loop, I'm going to return the primes. Okay, so the question is, should I already have a function that's defined in my math functions.py, right? That tells me it's a prime. Now I don't want to rewrite that function again in my app, in this file, my app, right? Doesn't make sense. Because already there is a file, I mean a function there. I want to reuse that function, right? So how can I do this? So in Python, what you can do is you can have this imports. It's called. So you can say import whatever that file name. Okay. So basically in Python, every file is called a module. Okay. So this is how we import another module. So if I say import my math functions, okay, so basically it'll bring in all the functions, all the variables, everything into my app. Okay. So in order to access any of those functions in that module, my math functions module, what I need to do is I have to call it like this: my math functions, the module name, right, dot is prime. You see all those functions that are in the module show up here, right? I had the main method and the is prime method, function, main function and is prime function. So I can just call is prime and pass in the I. This basically executes the same code as I had in here. Okay, so this allows me to reuse function. You guys see it? All right, so let's test this get primes. So I'll just write a main method here. So let's say I create a list of numbers. Okay, 1, 3, 5, 10, 28, 29, 19, whatever, 47, 49, 61. Okay, so given a list of numbers, if I pass this to my get primes, right, it should only return me all the prime numbers in this list, right? So and I'm going to just print this out. Okay, so if I run this method, run my main method, it should print out, right? It should only print out just the prime numbers in this list, right? So let's run this. Something unexpected will happen. Okay. What's happening? Okay, actually, let's get rid of this.
It's also incrementing the previous function.
No, it's actually calling the previous. Okay, let me just get rid of this. Okay, I'm just going to print it like this. Okay, here's our list, right? I'm just printing the list itself. And what is all this stuff here? Where is this coming from?
The my math. We're printing it in the other one.
Yeah. So we're basically, this method that got called here, it automatically got executed because of this import. So what happens is that when I import, not only does it bring in all the functions, it at the same time it executes my main method. Okay, so it executes that, then my main method here in this my app function gets executed, that prints the primes as a list here. Okay, so the important thing is don't worry about the implementation of this prime, and but you guys need to see what is happening. So when I import another module, it basically executes everything. At the same time, I also have these functions available to me under this module name called my functions. See, I cannot call is prime. I have to call my module, whatever the module name is prime, like dot is prime. Similar to how you call list dot append, list dot, all those methods in the list. It's similar to that. Okay, so you use the dot and then the function name in that module. Okay, file in a Python is a module. So obviously we don't want to print this thing, right? This is part of the other module. So how can we suppress this? Actually, Python gives us a mechanism to suppress this. Okay, so let's go back to our function here. I want to print something. Okay, what I want to print is in this main method. Okay, so before I print this, if you remember in the Python console, right, there's, when you run this, there's this special variables. Okay, I don't know if you looked at it, but there are special variables that are that the variable names start with 2 underscores, and then the name or whatever the name of the variable, and then an underscore. Okay, these are called special variables that are created by Python for us automatically. Like in our code, we don't write any of this underscore name, right? It's automatically created for us when we run this program. The reason why why Python gives us these special functions, we will find out why. Okay, so by the way, these double underscore, these variables are called, like the way you would read this variable name is called dunder name, or dunder file, or dunder built-ins, dunder doc, dunder. It's called dunder. Okay, double underscore. So it's a Python convention to call these dunder variables. Okay, so dunder name is a special variable. So we will print out this variable to see what the value for it. Okay, so remember my math functions. I'm just going to print out this variable. Print. I'm going to say this is dunder main. Just going to give it a name, right? I'm going to print this variable dunder main, or sorry, dunder name. What am I saying? Dunder name. Sorry, dunder name is the special variable that gets passed to us. Okay, so Python doesn't complain. See, normally when you put something, it might complain, but here it doesn't complain anything because it knows it's a special variable that's coming in. Okay, so let's run this. I'm running my math functions. Okay, the original file. So you can see when I run this, it says name is dunder main. Okay, name, let's put name equal. I'm just going to put equal just to make it more clear. So the name variable, the special variable, is assigned the value main when I run the program here, right? So now in my app, let's copy that thing again in my app and print this. Let's run this program. So what do we get printed? Okay, let's so it's kind of, let me just print a new line here at the end so it doesn't confuse us. So if I run this, you can see in when I ran my functions, the dunder name was main, right? If I just run that, now I'm going to my app, which imports my math functions, and I'm just running my app here. When I run my app here, the name dunder name in my math functions is no longer my underscore main, but rather it's my math function. It's basically the name of the file itself. Do you see that? So we can use this dunder name. So we can conditionally execute our main method only if dunder name is equal to main, because that's when we know that our application is, like, somebody wants to explicitly run our application compared to when our module is imported. Okay, that's the way we can distinguish whether our file is being run as a program or run because it was imported by another module. Do you see it? So if dunder name is the name of the file, then we know it's being executed as part of the import statement. Okay, and we don't want our main functions to get executed when somebody imports a function, right? Usually when somebody imports a functions, it's because they want to reuse some other stuff that we wrote, right? Such as here. Everybody clear? Yeah, Vaishna, you understand? Any questions? Huh? You have any confusion on this?
Yeah, why did it change?
Yeah, so Python knows, it's like a hint for us. Python gives us a hint that says if dunder name variable is main, then it's that file is being executed as like here, like when I run this program. But if dunder name is not main, if it has the name other than my underscore main, that means it's getting executed because somebody imported our function, imported our module in another file. Okay, so
Okay.
it just Python is the Python is giving us a hint where it's being executed from. So normally that's why we don't in Python you don't execute main method right away like this. What you do is you only execute main method if underscore main variable is equal to dunder main. This means it's getting sorry, dunder name. Why am I typing dunder name? Dunder name. Okay. So if dunder name variable is main, then only I need to execute the main method. Okay. So we will copy paste the same thing over there. Okay. So from now on, we should always say if dunder name, only if dunder name is equal to main, then only we need to execute our main method. Otherwise, somebody is importing our functions or our module in some other application, and we don't want to run our main function. Okay, so now let's run this program now. So if I run this now here, this is same as before. I'm just running this module, this file, and the name is main. Okay, now when I run from here, remember when I ran it, dunder name for this module was the name of the file, right? When I run it from here. So because of that, and we have a conditional check here, this main method won't execute. So this program, this main program in this my math functions won't get executed. So let's run this. You see, the previous, we don't have that output anymore. Do you see that? Because
So that's a way to, if you're going to import something you don't want to print it, you could just do that.
yeah, basically we always want to make sure that whenever we call our main method, we always check the dunder name, and only if it is main, we execute our main method. Okay, so that's why if it's like a convention. So if you create any file, right, say app, and if I say main, it automatically puts this PyCharm automatically puts this if dunder name equal main. You would have come across this, right, when you try to create main and you hit enter. I don't know if you have, but always it does this. So it's a convention in Python that whenever you want to run your main method, just make sure that the dunder name is equal to main. Then only you execute the main, because your module could be imported by someone else, and they probably don't want your main method to run, but rather they just want to get your functions in their program so they can reuse those functions. Okay, clear, Vaishna? Does that make sense?
Yeah.
So this condition here, it just allows us such that when somebody imports a module, which is our file, we don't want our main method to get executed, but just only the functions in our module. We want the functions in our module to be accessible to the other person who's importing our module. That's the only reason why we need to put this. Okay, clear? This is only because when we write more like bigger programs, we need to split our logic across multiple files. Also, that's one reason. Another reason is, for example, like we don't want to rewrite our functions, like these common functions that we will use again and again in our file, right? We only need to write them once, and then we can reuse those. You see how we reuse, right? As prime, we reused them in here, right? We didn't have to rewrite the function in this file again. We are importing that module, and all the functions in that module we have access to. Make sense? So this is called importing modules. Okay. Okay, so there are some other properties of this import. Let's say right now my math functions is such a long name, right? If I decided, I could give it an alias for my math functions. So if I say import my math functions as like my math, okay, if I rename it like this, I don't have to use my see, it says my math functions is under, like it has a squiggly underline, right, red. So it says unresolved reference. Because we renamed it, or we gave it an alias, okay, we have to use that name. Okay, that's just a way to rename. Okay, still works our function, our program, but this is just another way to rename whatever the module that we import. Like especially if it's a very long name, we don't want to keep typing that again and again. Okay, so I can give it any names. I can give it mm. Okay, mm, my math, and run this. Still works. Okay, so this is just a way to alias. Confusing? No, right? Okay. All right. So there's one more thing I want to say. So my math functions, let's say this is just one function we have. Let's say we define some more functions. Okay. Some add function, AB. Okay. Our old function. Of course, there's no real reason why you would create this add function. It's just a plus b, right? So I'm just only showing this as an illustration purpose. Okay, let's say we had more functions: add, subtract, and so forth. Okay, so suppose since I'm importing this module right? I mean my math functions as and what I will get is all these functions, right, inside the right? So now if I say somewhere here dot, I will see all the functions are available, right? But sometimes what you want is that you don't want all the functions in that module. You might just want let's say for example I only need is prime only. Okay, for whatever reason I can also do something like this. So instead of import, okay, I can do from my math functions import whatever the functions that I need. So in this case I just need the s prime. Okay, I can say import s prime. So this is a little bit different. I'm only importing that functions from that module. Okay, not everything in that module, but just that function. Okay, when I do that, I no longer have this I can just simply call s prime as I would if I had that function written like written in my file in this file. Like if I had def is prime, right? It's similar to if I had it like this. I'm just calling it. I'm not prefixing with that the module name. Okay, so this will also work. Okay, so this is just another way of importing just that function, only that function. Confusing? So the other one we imported everything. That was just import my math functions and then we can give it an alias as whatever. Here we're just only importing that function from that math module. And also I can rename this function to something else too. Like here it was called is prime, right? I can just call this p or whatever or pr. And if that is the case, there's no longer is prime there. So since I renamed it to something else, I have to call it like this. Okay, this will also work. So it's just a different variations, okay, of importing a module. Basically all these things import some code from another module. That's all this thing does. Either you do import the whole module, okay, or you import some specific functions from that module. In both cases you can rename it to whatever you know, whatever name that you like. The reasons why you would want to rename them is such that, for example, let's say if I had another function in my file called is prime for whatever reason, okay, I'm just going to pass here. Okay, I don't want this is prime to be a collision with this function in here. You know what I mean? Because I have a function named is prime, and when I bring it in to this file, if I already had something like that with the same name, the Python will say wouldn't know which function I'm referring to when I call it. Okay, because I have two functions with the same name. So in those cases, I can rename the function that I'm bringing into my module. Okay, so it is clearly distinguished. Make sense? All right, so that's all for now about modules. Okay, so modules are basically files that we want to bring into our program. Okay, so Now I know I said that we will talk about unit testing, right? Um, how do we write programs that uh, you know tests itself basically? So for that, um, I want to bring your attention to Python documentation. Okay, so if you go to web, right, and you type in Python documentation, let's see, Google. You will see right now the latest Python version is 3.91, and you go to the documentation page, it shows you, okay, here. Now this is the latest version, 3.91. There's older versions. We can switch here, but if you go to library reference, okay, this shows you what are the standard. So this is the Python standard library, which means it has a whole bunch of modules already pre-built for us to use. Like for example, the list, the dictionary, all those things are coming from the standard library. We are able to use these. Okay, so if you scroll down, it will tell you, for example, the built-in types. Remember the int, float, right? List, tuple, range, string, all these things are coming from the standard library. Okay, so standard library gives us the types, the built-in types, as well as all other modules that we can use. Okay, for example, string, we get all these functions. Okay, we can use these things. And for example, Python also has math module. Okay, we can use all these functions in this math module. So things like, finding out the greatest common divisor, it's already defined for us. Okay, somebody took the effort to write these functions. It's already built in the Python module. So I want you to go and have a look at all these functions that are available. I mean, if you don't worry about all the complex ones, because we haven't um, looked into those yet. But things like, remember the date time we calculated, the number of days in between two dates? Python already gives us this date time module, which can easily do that. Okay, so but it is somebody wrote that code. But the reason why we didn't want to use these modules is like we are learning coding from the very basic, right? So we need to know how to code regardless of whether there is some code available for us or not. We should be able to create everything from scratch, right? Because that's the basics of programming. You need to know the basics before you start using these modules. Okay, so there is a whole bunch of modules that are available for us already to use. One other thing is called unit test module. Okay, that's what we want to look at. It's called unit test. So what this is basically this is a new, so don't worry about this class and all this for now. Basically just focus on these methods. Okay, so let's go back to our assignment number. Let's see, let me just close this. Okay, we don't need this. So if we go to our GitHub repo, so for assignment number 4, if you remember, I asked you guys to write a bunch of like small programs, right? Remember that? So one of the things that you'll find here is I wrote this test.py. Okay, this is my solution, by the way, right? All the functions defined. Okay, so now I have this test.py. If you open it up, okay, don't worry about all these things for now. So you can see up here I'm importing the unit test module. This module is given to us from the Python library, as well as I'm importing solution 4. Solution 4 is basically this file here that has all the solutions, right? All the functions. So when I do this, I have the unit test module available for me from Python, as well as my code from solution 4. Okay, so now don't worry about, you can just say class whatever. Okay, this one I'm saying test assignment 4. It's basically I'm saying that I'm going to test my assignment 4 solutions. Okay, you can just copy paste like this unit test. You don't have to worry about this for now, but what you can do is inside this block here called class, you can define these methods. So my methods, for example, it's called test minutes in between, right? Remember in assignment 4 we had this this function that's going to calculate the minutes in between 2 times, right? So I wrote this function. Normally what I would do is test is in my main I would pass in some arguments and make sure that this function is working properly, right? Again and again. That's kind of tedious, right? So if I had many functions and I would have to do this again and again, like basically write all these main in my main, all these things, right? That's what we have been doing, right? So what unit test does is that we write these functions that are going to test our solution function, basically our functions. So here what it's doing is, don't worry about the self keyword and all that for now. So you can use all these assert methods that comes in this self object. Okay, what it does is it checks whether this is our expected value, and here we are calling our function with the arguments that we want to test for. Okay, so I'm saying I'm calling you solution 4 dot minutes in between. I'm passing all these arguments. For all these arguments I'm expecting the result to be 0, right? So this is the expected result and for this call. Okay, so I write these asserts basically in my function. So this function, the only responsibility for this function is test my minutes in between function. Okay, so I'm just calling these functions and I'm making sure that the return result is equal to the expected method. Okay, that's what this assert does. It checks whether these two are correct. If they're not this equal, it'll warn us basically when we run this. So if we go and let's say, for example, let's create a test case for our prime number. Okay, so I'm going to call this test prime. Okay, so we will do similar to this. So we will import unit test. Okay, I'm bringing in a module called unit test that is given to me by Python, and then I'm going to bring in my code that I wrote for the prime, right, which is in my math functions. Okay, so I have two imports. One is the unit test and the other one. Then I would just say class test prime. Doesn't matter what name I give it. Okay, but within this bracket I need to have this. Okay, we will learn about what this means, but for now don't worry about it too much. Okay, then within it I will say def test, whatever the name. I'm going to test my prime. Okay, test is prime. Okay, Python automatically puts this self. Okay, then all I have to do is I'm going to say self. I'm going to test my program. So tells assert equal, right, similar to this. There are a bunch of asserts, but for now we'll just only look at the equal. This method basically checks whether expected argument is equal to the actual argument, actual value. Okay, this is the expected value and this is the actual value that's going to come. So we would say, so this, for example, it has to say for number 2, right? So I will call my math functions is prime. If I pass 2 to my prime function, it should return me true, right? Because 2 is a prime number. It should be able to behave like that, right? And let's say self assert equal if I call with, for example, if I say 1, is 1 a prime number? It should return me false, right? 1 should not be a prime, right? So these are my assertions, basically. This is how we test our program. Okay, we're passing in, we're explicitly calling our functions to see if it returns the expected result that we are expecting. Okay, so if we want to run this method, we just click this plus here. So it runs and it says okay. Okay, so if it gives us okay, that means everything passed, basically. Suppose if I had in my prime function, let's go back to our prime function, instead of 1, for whatever reason that I made a mistake, I put true here. Okay, so I'm saying 1 is a prime number in my function, so my function has a bug, right? This should return me false, but it has a bug. So if I had written my test case like this, and if I rerun this, I will be able to catch this right away. It says failed, the test case failed. Okay, it expected false, but actual was true. And if I scroll down, it'll tell me exactly which function, sorry, not that. It'll tell me exactly which statement failed, right? Assertion failed, basically. This assertion, asserting whether this value is equal to whatever that's returned, it failed. So my test case failed. My expectation that this function should return false didn't happen. Instead, it returned true, right? Actual was true, but the expected was false. Do you guys see this? So this is very helpful, right? So whenever we write our programs, we can write our test cases, right? And have this run again and again to check whether our function is behaving as it should. Especially when we wrote our big program, right? The cipher, the encryption, decryption, we had many functions, right? If we had, for each function, if we had these test cases, we can be sure that our function is behaving as it should, as per our expectations, right? We should be able to catch this early if there's anything wrong, if we write the test cases. Writing test cases is a lot of work, as you can see, right? But it'll help you. Like you don't want to just, usually what we did is, up until now, we write our big program and we run it. We explicitly, like for example, the cipher, the encryption, we have to type in again and again, right? Until we get our program to working, right? So, but if we want to avoid that, we can write our test cases for each functions that test this again and again. It's going to save us a lot of time, right? And it's all automated. We can just run this and it's going to go boom, 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 by like it's just going to execute one after another and see if the expected result is what we get.
How do we check it again?
You can run all the functions within your test class, like run here, they'll run everything, or run just that individual function. Okay. Yeah, and usually you want to have lots of test cases, like all the corner cases, everything, you will cover it here. Yeah, like I had it here, right? I had a whole bunch of asserts for just that testing minutes in between. Again, for the Fibonacci, I had a whole bunch of asserts. Okay, so for each function, you will have lots of asserts. The more you have, you're covering all the corner cases, so you don't find something unexpected, right? So always think about when you write a program, think about how you can break it up into functions such that your program can be testable by these unit test cases. Okay, so remember, Waylon, you had the one main function and you had a whole bunch of things in there. This is the reason why you don't want to, one of the reasons why you don't want to make your function so big. Then it becomes very difficult to debug, right? If you break up individual sections into these functions, you can test them. So you know that section works good, then you can just focus on the rest of your program. So this will help you to avoid those frustrations. Okay, but it's more work. You have to write more test cases. Basically, it has nothing to do with your main program. These are just tests. Okay, it doesn't influence your program in any way whatsoever. It's totally separate. It's just testing your functions. That's all it's doing. Krishna, you're like, you're bored. Make sense? Is it going to help you? It should, right?
Why would we do this instead of we could just test it ourselves, like with the just calling the function?
Yeah, but how many times? It's not automated, right? You have to spend time testing it, entering the input, right? No? This way you don't have to. You just write it and you just click once and it's going to run again everything that you have. Especially when you're writing a big program and you find out there's some bug, you go and change some functions, you might break your expectations of how it behaves. But if you have these functions or unit test cases, if you rerun them, you'll be able to catch whether some changes that you did to your program breaks the existing functionality or not. Okay, this will be able to catch it.
I can't get the testing to run.
I think they have to be in the folder, like the orange.
What did you do?
Because when I click on the green arrow, it just shows the run lesson and run the file and then debug the file. It doesn't have another option.
If you click and you should say run unit test cases.
It doesn't for me.
Can you share screen?
You have to stop.
Yeah.
Yeah.
Yeah, if you click on that, what does it show? Run debug. Oh, why does it do that?
Open up lesson 8.2 or 8.
Okay, just go to that file and say right click on and say run. Right click anywhere. Yeah, run. No, not run. Just right click. Is there any other options?
Maybe because he's using 3.3. PyCharm 3.3.
No. That's not the reason. How about you, Krishna? Were you able to run it? Did you write it?
I didn't write it. I just took screenshots.
Okay, so we will figure this out. Okay, why it doesn't do that for you? There might be some PyCharm issue. If you go to the run menu, what do you see? At the top here, run menu.
Here at the top,
No,
right here.
the top, way up. Run. You know the menu. Run. Yeah. Run.
Oh, okay. Yeah.
What do you see in here? Say, click on that run dot. Say, yeah, unit test case. Okay, there you go.
Okay.
So now just click on the plus again. I mean the play button. Does it run it? No, I mean the play button on the editor.
Oh, now it's here.
Okay, I don't know what happened.
Now it's here.
Yeah.
Oh, okay. Thank you.
Something wrong with the pie chart. I don't know. Okay, so what is this? So that's for unit testing and importing modules. Okay. Okay, so for next assignment, this week's assignment, how many of you know what a matrix is? Matrix, not the movie. You learned about matrix?
No.
No? All right, go to Wikipedia. So matrix is basically a tabular. Remember we had that list of lists? That's basically what a matrix is. Okay, it's basically numbers that are basically rows of numbers which have a bunch of columns. Okay, here we say this is a 2 by 3 matrix. So
You're not sharing your screen.
I'm not
oh,
sharing.
sorry. Ouch. Okay. Let me see. All right, you guys see it? Yeah. All right.
Right now, all I see is a black screen.
Black screen.
I can see it.
Okay, now
I
I
can
can
see
see
it.
it.
Oh,
Yeah.
okay.
Okay. So I just went to Wikipedia matrix. So it's basically a grid of numbers. Okay. So here for this example here we say it's a 2 by 3 matrix because we have 2 rows and 3 columns. Okay. That's what a matrix is. So if you have 2 matrices, let's open up my CRID app. Just gives you some example. Okay, so that's for simplicity's sake. So if I have a 2 by 2 matrix, let's say I have 1, 2, 3, 4. Those are my elements. Okay, I have 2 rows and 2 columns. Okay, if I want to add with another matrix, let's say I have 3, 4, 5, and 6. Okay, the way how you would add is this element and this elements gets added. Okay, so new resulting matrix is the same dimension as the original matrix. This is 3 plus 1 is 4, and then this one with that 3 plus 4 is 7, and this one 2 plus 5 is 7, and 6 plus 4 is 10. Okay, this is how matrix addition works. You don't have to know what there are many applications for this matrix, like everything from like for example even Google search algorithm, right? It uses matrix to find out what is the most visited site is. Okay, that's one thing. There are many applications. Okay, another is in computer graphics. When you move around in your program, your character, when the scene shifts in 3D, underneath everything is happening in as matrix computations. Okay, so there's a whole bunch of applications for matrix. Okay, but we're just only looking at some operations on what we need to do on the matrix. So if you have a 2 by 2 matrix, you can only add another 2 by 2 matrix, and the way you add it is just element by element, right? So the row column has to correspond to the other matrix row column, and those values needs to be added and put into the new result. Okay, so this
Do they have the same like the same amount of grid?
Yeah, same size. So the dimension of this grid has to be same. So this is a 2 by 2, but I could have a 2 by 3, right? So 1, 2, 3, 4, 5, 3 or something. So if I want to add it, I can only add it with the 2 by 3 dimension matrix. Okay, I can add it with a 2 by 2. It has to be the same dimension. Okay, so it's like 0, 0, 1, 1, 0, 0, 1, 0, 0. Something like this. You can see you just have to match the element, the position. Okay, so here will be 1, 2, 4, and here would be sorry, what, did I have an extra row? So I have an extra row here. Sorry, this doesn't exist. It has to be the same dimension. Okay, so I had a 2 by 3. I have to have a 2 by 3. Okay, so 4, 5, 3 would be 4, 6, and 3. Okay, so this is called matrix addition. Okay, now matrix have another operation called matrix multiplication, which is a little bit more complex. So how that works is that, let's say I have a matrix dimension of 2 by 3, and I have another matrix called 3 by 4. Okay, so this is the row, this is the column. Okay, so row 1, column 1, row 2, column 2. Okay, 2 matrices. So if I want to multiply 2 matrices, the column of the first one has to be equal to the row of the second one. Okay, and how it works, let's say we have an example here, 2 by 3. 1, 2, 1, 0, 1, 0. Okay, and I want to multiply with so that's 2 by 3, right? 2 3s and 3 columns. Now I need a 3 by 4. So that means I need 3 rows, and these ones doesn't matter, number of rows and number of columns. So number of rows of the first matrix and number of columns of the second matrix doesn't really matter for multiplication. It's just the column of the first matrix has to be equal to the row of the second matrix. So what that means, let's just go through the example. Okay, so we need a 3 by 4 in this case. So let's say 1, 0, 1, 2, 0, 1, 0, 2, 2, 1, 2, 1. Okay, something like this. Okay, these are the numbers. So I have a 3 by 4 for this guy. So when we multiply, the resulting matrix size would become this outer one, 2 by 4. So it will be a 2 by 4. It's 2 rows and 4 columns. Okay, so how we multiply is like this. We take this first row, right, and then we take the first column, and then we multiply these individual elements one by one. So 1 times 1 is 1, plus 2 times 0 is 0, plus 1 times 2 is 2. Okay, and then we add all these values. So 2 plus 1, that is 3, right? So the value here would be 3. And then we do the next one. We take the row and we multiply with the next column. Okay, so in this case it will be 0 plus 2 plus,
Chitapa.
yeah.
I have to go pick up my instrument for school. So I have to go right now.
Okay. All right, so this is basic. I'll continue. I'll explain to these guys. You can watch the video.
Okay, sure.
Okay.
Okay, bye.
Bye. So same row by column. Okay, so here this value would become 3. Same for the next one, row by column. So in this case it will be 1 and 3. So again 3. Next one will be 2, 4, 5 and 6. Okay, So that's the first row. So we keep multiplying, right? Row by column. Okay. Now then, so we have first row here. The second row would be this row. Again, we multiply the column again and again. So in this case, it will be 0, and this one is 1, right? And this one is 0, and this one is 2. Is that correct? I hope I did it correct. Yeah, row by column. 0, 1, yes. Because we have zeros here, when we multiply it, it's 0. Okay, so that's how matrix multiplication works. Okay, so the inner, basically if you have two matrices, the first matrix column must be equal to the second matrix rows, because we have to take the row and multiply by the column. Okay, so this was our next assignment. I'm going to post you guys. So you have to have a command line interface like we always have. It has to ask whether they want to do an addition or multiplication, and if it's an addition, it'll ask for the dimension, and it'll ask you to ask the user to enter the rows, right? And it has to print out the calculated matrix. And for the multiplication, it'll ask 2 dimension, and it has to also make sure that the dimensions are correct. If the user enters some wrong dimension here, let's say 2 by 3 and 1 by 4 or something, that doesn't match up, right? The column doesn't match up with the row, you have to warn the user. Okay, and when he gives the correct matrix dimensions, you have to multiply all this and produce this final multiplied matrix. Okay, so that's going to be the assignment, next assignment. Okay, I'll post it tonight or tomorrow. Okay, so that's it for today's class. Okay, any questions before we sign off? No questions? All right, bye guys.
Bye.
See you guys next week.